So the question is minimum increment to make array unique. In this question, basically we are having an array nums and there are elements in the array. In each move, we have to pick any index element and increment that element by 1. And in that way, we have to do this moves and return the minimum number of moves we have to do in order to make every element in the array unique. So we will be thinking like first we will calculate the frequency of each element and then we can apply something, solve it using greedy approach. First, let's take the maximum element using the star max underscore element function, and n is the size of the nums array. And let's take an vector of counts of size n plus max element plus 1. We will give the reason behind taking this length counts vector in the end. Let's at this time let's take this as an counts vector. Now we will iterate in the counts vector. If the counts of I element is less than equal to 1, it means either it is not coming or the frequency of the element is 1. So it means that it is already unique. It is present in the array only one time. So we will continue for the next value. Then if the value is greater than equal to 1, now we have to do something. First we will make the iterations like moves. We have taken a move integer initialized to 0. Now we will increment move by the counts of I minus 1, because counts I is the total frequency count. Suppose it is 3, so we can keep one count as that element because it is unique, and we have to move two elements counts I minus 1. So we will add counts I minus 1 in the moves, and both of that element we will add in the counts I plus 1, so that then we will check for I plus 1th index. We can make that count from that. So here we are using a greedy approach. At max, at this current time, what we are having is what we have knowledge. We are using that knowledge and making a locally optimum solution that will lead us to eventually global optimal solution. Second, so here why we have taken n plus max element plus 1 size array. Suppose there are 4, the nums dot size is 5 and all elements are 4. So the frequency of 4 is 5, and we have to make that frequency because the element 4 is last element as the nums of size is 5 only. We have to move that frequency 5 of 4 to further 6, 7, 8, 9. So if the frequency of 4 is 5, we can keep one 4 at 4, and all the other 4 we have to make 5, 6, 7, 8. So we have to keep the array size n plus max element plus 1, because we have to make that 4, each 4, 5, 6, 7 and 8 value. So that is the reason behind taking the vector length as this. The second approach is of sorting. We can sort the nums array and then we can check if we will start the loop from I is equal to 1 till end. If ith index element is less than equal to I minus 1 index element, then we have to increment the nums I minus 1 plus 1 minus nums I to our moves, because this move we have to make, and update the nums I plus 1 with nums I plus 1. So here, using this approach, we will make the solution, but it will be take n log n time, because we are first sorting our answer. Basically, what we are doing is, in this approach, suppose there are two ones, so we will increment that one and add the increment in the moves and update that value. So yeah.